On Wednesday, when a lot of students weren't here, we did the notes for 7.5 to 7.6, which is our first section about trig functions or trigonometric functions. We did some basic notes, and then we reviewed for the quiz. So you didn't really miss any practice for this. We just did the notes, and they're going to practice today, Thursday, during class. So hopefully this video will get you caught up, and you'll be able to complete the practice today in class. So a trigonometric ratio is a ratio of the lengths of two sides in a right triangle. In a right triangle, you always have an opposite side, so opposite from an angle. You have an adjacent side, so adjacent to that angle, and you have the hypotenuse. So we're going to talk more about those in just a second and how they relate to these ratios. You can use trigonometric ratios to find the measure of a side or an angle in a right triangle. Notice it has to be a right triangle for these to work. You can use the phrase SOHCAHTOA to help you remember the trigonometric ratios. So the way you want to write that is a capital S and then an OH. Capital C, AH. Capital T, OA. So if you're someone that's had pre-calc, this should be familiar to you. You might have even heard SOHCAHTOA in Algebra 1 or a little bit in middle school. What it helps you do is remember what the ratios are for each trig function. So our three trig functions are tangent, sine, and cosine. And what they help us do is sometimes in a picture, you're given one angle and one side. Pythagorean theorem doesn't work. Special right triangles doesn't work. So this is just another way to find missing parts of a triangle. The first one is called tangent. If you look at our acronym here, SOHCAHTOA, the capital T, OA, means that the tangent is opposite over adjacent. So you take the opposite side over the adjacent side. This symbol here just represents, it's like a variable for an angle. It's called theta, and again, it just represents an angle. So it could be angle B, or it could be angle A. Now sine, so, S-O-H, the sine function is opposite over hypotenuse. And lastly, the cosine, represented by the C-A-H in SOHCAHTOA, is adjacent over hypotenuse. So now we're going to practice how we can identify these ratios in a triangle. So what I want you to do is take a marker or a pen or something and highlight angle A. We're going to talk about angle A first. Now with respect to angle A, so notice that's the angle we're focusing on in all three of these ratios. You need to figure out what's the adjacent side, what's the opposite side, what's the hypotenuse. So adjacent is next to it, so it would be X. Hypotenuse is across from the 90, the longest side, so that would be Y. Opposite is the side across, so that's going to be Z. So when we fill in our ratios, we just have to identify what's opposite, what's adjacent, what's hypotenuse. So we said the tangent is opposite over adjacent, or Z over X. Again, Z is our opposite side from angle A, X is our adjacent side. The sine is opposite over hypotenuse, so O over H, or Z over Y. And lastly, the cosine is adjacent, so X, because that's our A side or our adjacent side, over hypotenuse, which is Y. And usually we're going to work with numbers when it comes to these, but we're just practicing with these variables X, Y, and Z. Now the only time these ratios change is if you're looking with respect to a different angle. It's almost like you're looking from a different perspective. So now if we do B, and we highlight angle B, we have to figure out what its sides are. H is always going to be the same. That never changes. It's not like the H moved or anything, so it's going to be the hypotenuse. It's the opposite and the adjacent that switch, because now the opposite from angle B is O. Next to angle B, or adjacent, is A. So Z is now the adjacent. So they just switch places. So now let's find the tangent of B. TOA, remember, opposite over adjacent, would be x over z. Sine, remember, is opposite over hypotenuse, so x over y. Cosine of b is adjacent over hypotenuse, so z over y. And that's it for those basics. Now we're going to move on to part 2 and practice filling in numbers with these. So each one asks us to find tangent of S and tangent of R. So the same triangle, just two different angles. So I'm going to start with tangent of S. Here's tangent S. And we need to fill in this ratio. We need to figure out what are the three sides for angle S. Well, I know my opposite is over here. My hypotenuse is here. My adjacent is here. Your adjacent is always the side next to the angle that's not the hypotenuse. So when I fill in tangent, or opposite over adjacent, I say the opposite is 80, the adjacent is 18, and that simplifies to 40 over 9. Now when we do the tangent of R, again, we're just looking from a different perspective. So now our hypotenuse stays the same, but our opposite is 18, our adjacent is 80, because we're looking from a different angle. So the tangent of R is 18 over 80, or 9 over 40. Notice those just switch places. Now I want you to try part B on your own. So you can either pause the video and try it and then listen to the answer. Or if you're not quite sure or you just want to see the answer, I'm going to give you the answer right now. So on this one, the tangent of S, here's my S, opposite is 8, adjacent is 15. So it would be 8 over 15. Tangent of R, so here's R, opposite would be 15, adjacent would be 8. So it's 15 over 8. And that's it. If you can simplify a fraction, you want to simplify it, but that's all I'm asking for in this section. So sometimes just to practice understanding these ratios, we'll just fill in the numbers and figure out what the tangent ratio is, or the sine, or the cosine ratio is. Now, the last section is the most important because this is where these trig functions really come in handy. Notice in each of these triangles, I'm given one angle and two sides. But one of the sides is an x, or a variable that I don't know. The only time we've been able to solve a triangle where we have one angle and one side is when it's a special right triangle. So 45, 45, 90, or 30, 60, 90. Notice here, these are not special right triangles, so we have to try something else. What you do is you look at the angle that you're given, so 27. I want to know which two sides do they give me with respect to 27. They give me the opposite, and they give me the adjacent. So you need to think, if I have opposite and I have adjacent, which trig function do I use? And you should come up with tangent, because tangent is opposite over adjacent. So what we do to solve for x is fill in the ratios just like in the previous parts. Now instead of using s or r or theta, we can put the angle in here now that we have one. So the tangent of 27 is opposite x over adjacent 10. And now all we're left to do is solve for x. So you need to think mathematically, what would we do? What we would do to get x by itself is multiply by 10 on both sides, and we'd be left with 10 tangent 27 equals x. Now we need to figure out what this value is because this means nothing to us right now. Tan 27 is just a number, and we're actually going to use our calculator to get an actual numerical value for x. Now there's one really important step before you do that. You need to go to your graphing calculator and select mode right next to the second button. Again, you're picking mode. If you look down at the third row, Your calculator may already be in the correct mode, but most of them are probably in radian because that's what it's just defaulted to. You need to click arrow over to the right and press enter so that degree is now highlighted. So for this to work, you need to be in degree mode because we're using an angle in terms of degrees. Now what you do is you use these trig function buttons right above the numbers, sine, cosine, and tangent. 10 tangent 27 is 5.1. And that's it. That's our answer. Again, the tangent button is right here. So it's 5.1 for this answer. Now the next one gets a little harder to solve just because of the positioning. So let's look. We have 46. I see I have the opposite, and I have the hypotenuse. So think, which trig function would I use? I'm going to use sine, because sine is opposite over hypotenuse. So I write sine 46 equals, remember to put your angle in there. Opposite is 8 over x. Notice in the last one, my 8 was on the bottom, so it was really easy for me to just multiply by that number, which was 10 in that case, and get the x by itself. But now x is in the denominator, which presents a different kind of dilemma for us. So I'm actually going to show you on a different piece of paper, just so I have space, what we do here. So I have that sine 46 equals 8 over x. Some people think I'll just divide by 8, but if you divide by 8, x is still in the denominator. We need to get x out of that denominator by multiplying by x. So they cancel out over here, but it pops back up over here. So we have x times sine 46 equals 8. Now, this is where it's tricky because you're not used to these trig functions. Sine 46 is just a number. So you can divide by sine 46 to get x by itself. So x equals 8 divided by sine 46. And we can put this in our calculator. Now what I want you to notice is, this is what we started with. This is what we ended with. All that happened was that sine 46 and x switched places. Do you see now x is here, sine 46 is here. And that's going to happen every time you solve a problem where x is in the denominator. You can go through these steps if you like, if it makes you more comfortable, but if you can remember the trick, just switch those two terms. So I can rewrite this as x equals 8 over sine 46. In your calculator, you should get 11.1. And that's it. Now, I want you to try C again on your own. So you can pause the video now to try it on your own. Or if you're confused, or you'd rather just hear me explain or talk through it, then I'm going to talk through it now. So here I have 39 degrees. I don't have the opposite. I have the adjacent and the hypotenuse. So which trig function has A and H? That's cosine of 39. So it would be x over 7. Now we're back to that scenario like in A. I can just multiply by 7 on both sides to get this to cancel, get x by itself. So 7 cosine 39 equals x. In my calculator, 7 cosine 39 gives me 5.4. And that's it. So your practice today, you're going to be practicing problems like this. So hopefully you have some understanding. If you're struggling, you can either ask another student, because you're allowed to work in groups as long as you're working. You can ask another student for help. You can ask the substitute for help. So just please try. Don't just sit and be frustrated and then not get any of your questions answered. So do your best and try to get through as much practice as you can.